So, we ended up in the previous lecture the relationship between per unit your PE and TE. So, the terminal electric power in per unit is given by, that is we have seen earlier that PT is equal to ED ID plus EQ IQ. Now, substituting for ED and EQ from equation 192 and 193, if you do so, it will become PT is equal to minus psi q minus RAID bracket close into ID plus psi d minus RAIQ bracket close into IQ, or PT is equal to you can write after collecting those terms psi d IQ minus psi q ID minus RA into ID square plus IQ square. So, we know therefore, this we know this is the torque T. So, PT is equal to T minus RA IT square, because IT square is equal to ID square plus IQ square. This is equation 194, and this is actually nothing. This is for my own reference. So, air gap power measured behind RA, this also we have seen that P is equal to PT plus RAIT square, right. Therefore, whatever PT we have got, we will substitute here. This PT will substitute here. So, RAIT square will be cancelled. Finally, you will find that P is equal to TE, right. So, if you substitute, you will get P is equal to T, because RAIT square and minus RAIT square plus RAIT square will be cancelled, right. Therefore, the per unit air gap power P so computed is in fact that the power at synchronous speed and is equal to per unit air gap torque T. So, in per unit value, power and torque both are same, right. And we know the relationship normally that power is equal to angular speed into torque. Therefore, P is equal to omega r into T. However, the assumption of omega r is equal to 1.0 per unit in the stator voltage equation is also reflected in the torque equation, making P is equal to T. This fact is often overlooked, right. Now, next one is all these things we have discussed in the previous lecture. Now, next is I have written example 0, it will be example 3, I think it will be example 3, right. So, this is a little bit understanding is required for this example, because this is no data, but some proof, right. Now, with RA is equal to 0, suppose we are assuming RA is 0, because RA is very small, right. So, that for small perturbations the effect of neglecting the speed variation, that is assuming omega r is equal to omega 0, right, in the stator voltage equation is to counterbalance the effect of P psi d and P psi q terms. The meaning is that RA is equal to 0, say. So, we have to prove that for small perturbation the effect of neglecting the speed variation, that is assuming omega r is equal to omega 0 in the stator voltage equation is to counterbalance the effect of the P psi d and P psi q terms. P psi d means this is a differential operator, that is P is equal to d dt. So, it basically psi d dot and psi q dot terms, right. So, in this case, like solution with RA is equal to 0 and time t if we write in second, right. Therefore, the equation, your stator voltage equation 118 and equation 119, it becomes ED is equal to 1 upon omega 0 P psi d minus psi q omega r by omega 0. This is I have made an equation E1, right, and this is from equation 118, and from 119 that EQ is equal to 1 upon omega 0 P psi q plus psi d omega r by omega 0. In the 118 and 119 you substitute RA is equal to 0, then you will get equation your what you call equation 118 will be like this and equation 119 will be like this. You put RA is equal to 0, right. Now, suppose and we have made some assumption that your omega r, just hold on, that assuming that omega r is equal to omega 0, right. So, if you now take the small perturbation of this one, small perturbation of this equation, in the next page we will see that if you take the small perturbation of this one, so it will be delta ED, is equal to, it is 1 upon omega 0, right, P, then delta psi d, this one, minus your, it will be delta psi q into omega r by omega 0, but omega r is equal to omega 0, that we will write later. So, this is minus delta psi q omega r by omega 0, again minus your psi q, right, we are taking small perturbation, delta omega r by omega 0, right. So, if you take the small perturbation for, but omega r is equal to omega 0, right. That means this omega r, this term is unity, omega r by omega 0 is equal to your 1. So, that means delta, I am writing somewhere here, that means my delta Ed which actually is equal to 1 upon omega 0 p delta psi d, right, minus delta psi q, then minus psi q into delta omega r by omega 0. This is for small perturbation for delta Ed. This thing has been written in the next page, right, but just making it. So, similarly, if you take your delta Eq, so writing here, if you take small perturbation for equation E2, that is this one, for delta Eq, then here also it will be like this, delta Eq is equal to 1 upon omega 0, then p, then delta psi q, right, plus your delta psi d, then omega r by omega 0, then plus psi d into delta omega r by omega 0, right. So, that means this one omega r is equal to omega 0, this we have assumed, right. So, if you put omega r is equal to omega 0, this term is 1, that means here I am writing somewhere that my delta Eq will be omega 0, then p delta psi q, right, plus delta psi d plus psi d into delta omega r by omega 0, this thing written in the next page, right. So, if we take this your what you call this small perturbation, so that will be like this. So, omega r and omega 0 both are expressed in radian per second, right. Just hold on, we will go to the next page. So, sorry, just hold on. So, for small perturbation now, that whatever I wrote previously, right. So, this equation, that whatever I wrote in the previous page, the delta Ed will be this one, this is equation say E3, right. Similarly, I wrote for delta Eq, so it will be same equation, it will be this one, right. So, so in this case what is your in the previous case what we made it, that as it is a small perturbation, so there it is your what you call that your psi q into previous term, that psi q into delta omega r by omega 0, right. But when you make it, when you are just making a small perturbation, so psi q can be changed to psi q 0. Similarly, psi d will be changed to psi d 0, right. That is why previous case I did not write in the previous page, I have simply made your delta your psi q only, and this one also only psi d, but when you are perturbing around an operating point, say psi q 0, psi d 0, ed 0, eq 0 like this. So, it will be actually psi q 0 and it will be actually psi d 0, rest are okay, rest are okay. Now, how this psi q 0, psi d 0 coming, just one step, one complete calculation I will show you. So, in this case what happened, that you assume now that Ed actually, suppose initially it was Ed 0, psi d 0, psi q 0, eq 0 and omega 0. Now, it has been perturbed. Now, Ed will become Ed 0 plus delta Ed, psi d will become psi d 0 plus delta psi d. Similarly, psi q will become psi q 0 plus delta psi q, and eq 0 plus delta eq, and omega 0 plus delta omega r. Now, in equation E1 and E2, if you substitute and simplify, right, then how it will look like. Therefore, in equation your equation E1 and E2, it can be written like this. So, Ed 0 1 upon omega 0 p psi d 0 minus psi q 0, this is omega 0 by omega 0. So, this term will be 1 because omega r is equal to omega 0. So, I mean initially. So, if you put all the initial values only, that means your ED 0 will become your minus psi q 0. So, ED 0 will become minus psi q 0. This is because we have perturbed from ED, initially it was ED 0, now it is ED 0 plus delta ED. So, if it is ED 0 is equal to this much and omega 0 is equal, omega r is equal to omega 0, so this term is 1, right, and this is your initially it was p psi d 0, therefore its derivative will become 0, right, it was a steady operating condition. So, it is derivative is 0, that is why this term is also 0, therefore ED 0 is equal to minus psi q 0. Similarly, and also before going to that, also from here I have made it here that your ED 0 also we have seen earlier ED is equal to, we have seen earlier that ED is equal to ET sin your delta, right, and for initial condition that ED 0 will be is equal to ET, initial operating condition will be ED sin delta 0, that is why ED 0 is equal to written as ET sin delta 0, and that is nothing but this one minus psi q 0, right. So, that is your this is what this is some equation is marked, this is equation 1, similarly this is equation 2 will come to that, and this is 3, then this is equation 4 written like this. Now, similarly if you make it EQ 0 now, right. So, from the same equation, that is E2, from equation E2, this is actually equation E1, the previous page we have seen, just make it all the 0 0 initial operating condition. Similarly, for this one, this is actually equation E2, right. So, here also if you make like this, so EQ 0 will be 1 upon omega 0 p psi q 0 plus psi d 0 omega 0 upon omega 0, because omega r is equal to omega 0. Now, that means your this one, that this is the initial condition, initial operating condition. So, p psi q 0 its derivative will be 0, because p is actually differential operator, I told you dy dt, right. So, this term will be 0 and this term is 1. So, basically it will become psi d 0, right. Similarly, we also knew that previously we have seen that EQ is your what you call, just 1 minute, previously we have seen that EQ is equal to ET your cos delta, therefore, EQ 0 is equal to ET cos delta 0, right. So, therefore, this EQ 0 is equal to ET cos delta 0, and that is nothing but psi d 0, this is equation 4. This is all this what you call that ED 0 EQ 0, this can be simplified, that how one can obtain this, right. So, this is, let me clear it. So, that means now this one also look at that, this one also from in equation E1 and E2 you substitute all this relationship, first input in equation E1, if you do so, so ED will become ED 0 plus delta ED and is equal to 1 upon omega 0 p psi d will become psi d 0 plus delta psi d minus this term was there, that is your psi q will become psi q 0 plus delta psi q, and it will be your omega r will become omega 0 plus delta omega r divided by omega 0, right. Now, if you simplify then it then straightforward we can write minus psi q 0 plus delta ed, in between 1 and 2 step you do yourself, then some time will be saved from me, right, is equal to 1 upon omega 0 p delta psi d minus 1 upon omega 0, you multiply all, right, and simplify, it will be psi q 0 omega 0 plus psi q 0 delta omega r plus delta psi q omega 0 plus delta psi q delta omega r, right. So, in this case what, and ED 0, this there should not be any sort of confusion, and ED 0 we have seen ED 0 is equal to minus psi q 0, just in the previous page we have seen ED 0 is equal to minus psi q 0, and that has been substituted here, right, and this one multiplied and is equal to your whatever it is coming, right. Now, further if you do so, it will be minus psi q 0 plus delta ed this side is equal to 1 upon omega 0 p delta psi d, and if you simplify this one, it will be minus psi q 0, then minus psi q 0 delta omega r, this one will be what you call, this is this term is there, then second term psi q 0 minus psi q 0 delta omega r by delta omega 0, and this term minus delta psi q, and this term product delta psi q and delta omega r is very small. So, we have neglected that term because too small perturbation term delta term. So, it is very small. So, it has been dropped, neglected, right. So, therefore, we can write delta E d is equal to 1 upon omega 0 p delta psi d minus psi q 0 delta omega r upon omega 0 minus delta psi q. No equation number is given here, right. Now, since E d is equal to E t sin delta, similar way you can obtain delta E q also. Same way, in similar way you will substitute in equation E 2. In equation you will substitute E 2, that is your E q 0 plus delta E q, right. You substitute, similar way you can get the expression of your delta E q, that will come later, right. But I have not derived that directly, I have written, because one I have shown your complete derivation, right. So, now since we know that E d is equal to E t sin delta, that is equation E 5, and E q is equal to E t cos delta, that is equation say E 6, right. Hence, for small perturbation of equation E 5 and E 6, it will be something like this. So, it will be delta E d will be E t cos delta 0 into delta, right. So, and we have seen that your E t cos delta 0 is nothing but psi d 0, just in the previous just a few minutes before we have explained. So, E delta E d will be E t cos delta 0 delta, and E t cos delta 0 is nothing but psi d 0 that we have seen, right. So, that is equation E 7. Similarly, your delta E q will be minus E t sin delta 0 delta, that is your, and this one we have seen it will be psi q 0, right, into delta. This is equation E 8, right. So, all these things what you call, because we have seen that psi q 0 is equal to your previous thing, that your it will be minus E t sin delta your 0, right. So, that is psi q 0 delta. This is equation E 8. Just see that whether this is E q 0 E t cos delta 0 and E d 0 is equal to E t sin delta 0 minus psi q 0, right. So, that means all these things if you take this perturbation, so it will be psi q 0 your delta. This is equation E 8, right. So, once again let us go to your what you call E t sin delta 0. Here it is, right, that is your E t, look here E t sin delta 0, that is your minus psi q 0. So, that is why here we are substituting that E t sin delta 0 is minus psi q 0, that minus and minus plus. So, psi q 0 delta, this is equation E 8. So, understandable, right. Now, from equation E 3, E 4, E 7 and E 8 with delta omega r is equal to p delta, because we know that delta omega r, p is a d dt, p is equal to d dt, therefore, delta omega r is equal to delta dot, right, delta dot. So, that is nothing but your p delta, right. So, this is nothing but p delta, that is delta omega r. So, from equation E 3, E 4, E 7 and E 8, if delta omega r is this one, you substitute. So, if you do so, then psi d 0 delta will become 1 upon omega 0 p delta psi d minus delta psi q minus psi q 0 1 upon omega 0 p delta. This is equation E 9, right. Similarly, I told you that this step for E d we have derived. You please derive E q for that also, right. So, if you do so, and finally, same way if you proceed, then what you will get, that psi q 0 delta will be 1 upon omega 0 p delta psi q plus delta psi d plus psi d 0 1 upon omega 0 p delta. This is equation E 10, right. So, now we will compare the expression for delta E d and delta E q as given by equations E 7 and E 8 with and without the effects of p delta psi and p delta terms, right. With p delta psi means p delta psi d and p delta psi q, right. And now, part A, with both p delta psi means p delta psi d and p delta psi q. So, just we are putting like this and p delta terms included, right. Now, rearranging equation E9, if you just rearrange this equation E9, that is psi d0 delta delta, this equation if you rearrange, right, it will become delta delta will become 1 upon omega 0 p delta psi d minus delta psi q upon psi d 0 plus psi q 0 upon omega 0 p. This is equation E11, right. Now, from equation 10, I mean from this equation, equation 10 you rearrange, you will get your delta psi d will be psi q 0 minus psi d 0 upon omega 0 p delta delta minus 1 upon omega 0 p delta psi q. This is equation E12, right. Now, substituting equation 12 in 11. So, this delta psi d term you substitute in this equation 11, right. So, you just substitute. If you do so, then what will happen, and you simplify, you will get psi d 0 delta delta is equal to minus delta psi q. Such a small expression you will get. You put it, remember that all the derivative your psi q 0, p psi d 0, all these things will become 0 because these are a steady state operating condition, right. So, that means you will get, if you simplify, psi d 0 delta delta is equal to minus delta psi q. This is equation E13, right. Similarly, from equation E10, if you make it equation E10, you rearrange it, you will get delta delta is equal to 1 upon omega 0 p delta psi q plus delta psi d upon psi q 0 minus psi d 0 upon omega 0 p. This is equation E14, right. And from equation E9, that means from equation E9, this equation, right, this equation, from equation E9, right, you will get delta psi q is equal to minus in bracket psi d 0 plus psi q 0 upon omega 0 p delta delta plus 1 upon omega 0 p delta psi d. This is equation E15. Now, substitute this equation E15, that is delta psi q, in this equation for E14. You substitute and simplify. If you do so, you will get psi q 0 delta delta is equal to delta psi d, that is with E16. This equation is E16, right. Now, this is, I mean, whatever we have made it, right. That means considering both the, your what you call that you are considering your both p psi and are included. When both these terms are included, we got those expression. Now, so we got this E13, right, and we got this E16, these two equations we got. Now, with both p psi and p delta terms are neglected, p psi p delta terms means p delta psi d and p delta psi q terms are neglected along with p delta terms, these are also neglected. Now, that means in equation E9 and E10, with p delta psi d is equal to p delta psi q is equal to p delta delta is equal to 0, that means we are neglecting this. If we do so, you will get psi d 0 delta delta is equal to minus delta psi q, and psi q 0 delta delta is equal to delta psi d. This is E17, this is E18, and these two equations are same, that is E13 and E16. If you go to that E13 and check with E17, this is your equation E13, psi d 0 delta delta minus equal to minus delta psi q, right, and this is your psi d 0 delta delta minus delta psi q, they are same. And similarly, if you see that psi q 0 delta delta and delta psi d, and this psi q 0 delta 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 psi d and psi q 0 delta 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 psi d, these two are same, right. So, once that means including this term and you are neglecting this term, they are appearing to be the same thing, right. So, this is actually what we wanted to mean in the problem, right. Now, in this case, now next case is, suppose if we only p psi terms, p delta psi terms are neglected, and p delta psi d and p delta psi q terms say only it is neglected. If we do so, then from equation 9, with the p delta psi d terms neglected, p delta psi means, it is in general I am writing, that is nothing but p delta psi d terms and p delta psi q terms, right. So, with the neglected, then you will get psi d 0 delta delta is equal to minus delta psi q minus psi q 0 upon omega 0 p delta delta, right. Or if you rearrange, delta delta will be minus delta psi q divided by psi d 0 plus psi q 0 upon omega 0 p. This is delta delta. Now, multiplying both side you multiply by psi d 0, this equation, then you will get psi d 0 delta delta is equal to minus delta psi q and this one can be written as your side is 0 minus delta psi q, and this term into side is 0 by side is 0 plus psi q 0 upon omega 0 p, right. P is nothing, but I am making it here, it is nothing but that your differential operator. This is equation E19, right. Similarly, from equation E10, in equation E10 you neglect p psi q term, that is p psi q you drop, right. You make p psi q 0 in equation E10, and then we can show also that psi q 0 delta delta is equal to delta psi d, then psi q 0 upon psi q 0 plus psi d 0 upon omega 0 p, right. So, if you look into this, the above two equations differ from equation E13 and E16. These two equations are not same like your E13 and equation E13 and equation E16, right. So, next is with only p delta terms neglected, right, with only p delta terms neglected. With p delta delta 0 from equation E9 you put p delta delta 0, then you will have psi d 0 delta delta is equal to 1 upon omega 0 p delta psi d minus delta psi q. This is equation E21, and from equation E10 we have psi q 0 delta delta by putting your p delta delta term 0, 1 upon omega 0 p delta psi q plus delta psi d. This is equation E22, right, and therefore psi delta psi d will be psi q 0 delta delta minus 1 upon omega 0 p delta psi q. This is equation E23. Now, if you substitute equation 23 into equation E21, with this delta psi d term you substitute here and simplify, then you will get that psi d 0 delta delta is equal to 1 upon omega 0 p psi q 0 delta delta minus p upon omega 0 delta psi q minus delta psi q. Just you simplify, you will get this expression, or psi d 0 delta delta you will get minus delta psi q in bracket psi d 0, it is 1 plus p square upon omega 0 square divided by psi d 0 minus psi q 0 p upon omega 0. This is equation E24. Similarly, you can get this one similar way you move, right, and you will get this psi q 0 delta delta is equal to delta psi d psi q 0 1 plus p square upon omega 0 square divided by psi q 0 plus psi d 0 into p upon omega 0. This is equation E25, right. So, little bit I mean most of the things I have made it for you, but little bit you have to do of your own, right. So, again the above equations differ from E13 and E16, right. So, we see that the expression for delta Ed, that is psi d 0 delta delta, and delta Eq, that is psi q 0 delta delta, with both p delta psi and p delta terms included equal to this with both terms are neglected, right. So, if you include or if you drop, it is same, right, but not those with any one of these terms, right, neglected. Therefore, the effect of neglecting p delta delta terms is to counterbalance the effect of neglecting p delta psi terms. P delta psi means p delta psi d and p delta psi q, right. Thank you very much. We will be back again.